Good evening, everyone. I am Lakshmi Narayana from Zoho. Today, I am going to talk about our in-house Postgres extension, which provides graph capabilities. So before we further go, I will explain few graph terminologies. In this picture, Alice, Bob, Eve are known as vertices, whereas the arrows are known as edges. So the process of figuring out who and all Alice might know is known as traversal. So a graph traversal in a RDBMS generally looks like something like this. So for every hop, you require a self-join, and there will be no cycle detection by default. So our UDF provides a UDF-centric workflow. So the previous query now looks like a one-liner. And we also give graph-like performance. So to get started, you can mark your tables as vertex and edge. So in this example, I'm marking person as vertex and nose as edge table. If you already don't have a table, you can also use our APIs to create one. Since it's underlying a PG table, you can use your existing DML queries or DDL queries, or even you can use our own graph APIs. So let's take an example, same example of the recursive CTE. To get friends of Alice in a graph database, you will typically use this query, which is expressive and also very performative. But the problem comes when you want to use this data and do further relational analysis. So now you either add additional application layer logic, or you need to keep some of your relational data in your graph database. So since our extension is already under Postgres, it will just be a self-join. Sorry, it's a join against some other table. So how this is possible is our extension will return a tuple from our UDF. Once you return a tuple, PG will treat it as a table. So whatever you can do on a regular table can be done on this data also. It can be order by, it can be group by, it can be where. So how we capture data is, when you mark a table as vertex or edge, we'll internally create vertices. Triggers. So as part of your DML queries, we'll capture the data via trigger and put it into our storage engine, which is RocksDB. So RocksDB is generally a very high throughput, write throughput graph data key value pair. So, and it provides good prefix extractors and also gives probabilistic data structures. But the problem with RocksDB is it cannot reside in multiple processes. To solve this issue, we open RocksDB in a PG background worker and spawn multiple worker threads to provide parallelization. So your query will look something like this. So your PG backend will request for a graph query via IPC. So this will go to your worker thread, and your worker thread will read data in RocksDB and performs your graph traversal in worker threads itself. So the best part is your PG queries are not affected. This is like extensibility. So when it comes to our architecture, the main problem is PG is process-oriented, whereas our architecture is entirely thread-oriented. So any error propagation, interrupt handling, all these are not natively possible. You might need to do some hacky ways. And one more thing is RocksDB and PG are two different systems. So aligning their commit and abort is another challenge. So putting it all together, you either define a new tables or use your existing tables and mark them as vertex or edge and insert your data and just use our graph queries. So based on our experience, we think that Postgres can be extensible to provide any kind of graph, any kind of database workload. So it can be graph, it can be time series, it can be columnar. And with future upcoming SQL PGQ support, we are hoping that match query support will be natively available in Postgres. Thank you. In case of any doubts, you can mail me.